Yeah. Welcome everyone to what I think is definitely the most exciting track in the conference. You're going to be hearing from, and this is no hype, truly amazing speakers. So it's my pleasure to introduce our first speaker, Joseph Sirosh, now of Microsoft. My few words of introduction to Joseph. I first met him when he was at a small company called, well, it wasn't that small, HNC. I don't know if anybody remembers HNC. Yeah, they used to do fraud with neural networks. Now they are called Fair Isaac. He left Fair Isaac. I was trying very hard to hire him at Yahoo. He said no and went to Amazon. Did a lot of great things at Amazon with analytics. And then actually Satya Nadella himself dragged him to Microsoft almost 2 years ago now, or 2 years anniversary. And the distinction he has from me, actually, is I think Joseph gives the most reachable, most exciting talk about data mining, machine learning, and analytics. So judge for yourself. I'll let him tell you what he does at Microsoft with the cloud and his view of the clouded intelligence. So, Joseph?
Thank you so much. I don't know if I can live up to that introduction. Let me dive straight into the presentation. Mark Andreessen said about 4 years ago that that software is eating the world. So software is in the fabric of our everyday lives. But something very interesting is happening today. Cloud is eating software. So software is being delivered as services in the cloud. And not only is the cloud eating software, but the cloud is eating data. Data from every device, from every website, is flowing into the cloud. And when the cloud eats software and digests data, it produces intelligence. And that's the topic of my talk. Now, to show the transformation that this is enabling, let me actually show you the growth of data and then a fun, interesting story about how it's transforming some of the oldest industries in the world. First, think about the transformation that happened in the last 30 years with data. In the 1980s, the vast majority of the world's data was analog, books, gramophone records. Then CDs came along, DVDs came along, it became digital. The digital data, which in this graph is the blue and the green part, started growing. In the 1990s, when the internet came along, something very interesting happened. Data now had an IP address. This is connected data. Data started living in data centers and the cloud so much more than at rest on CDs and DVDs and on tape backups. It became addressable, it became computable, it became movable. And you see in 2015 that the vast majority of data in the world is digital. Analog has gone down to a very small amount. And at least half of all of that data is connected data, data that lives in the cloud, and it's computable. And you fast forward to 2020, you see that that data grows to about 50 zettabytes of data. That's 50 million petabytes of data. The vast majority of that data is green. It's cloud-born. It is living in the cloud. It's coming from mobile devices. It is from the Internet of Things. And that transformation has profound implications for us. The best way for me to bring that to life is with a story. So the story I'm going to tell you is a story called The Connected Cow. Now, it's a sexy story. It has all the buzzwords of today, the Internet of Things, the cloud, analytics. But it's also really, in many ways, about human ingenuity and how the Internet of Things and analytics can revolutionize even some of the oldest industries in the world. So let me tell you what I mean. So those are the connected cows that I'm talking about. See those pedometers on their legs? They're actually counting the number of steps the cow takes. I have one of them. It's made by Fujitsu. The cows in the dairy farm, every step the cow takes is being counted, sent to Azure. There's a service in the cloud that Fujitsu maintains that's analyzing the step counts of cows in a dairy farm. So you might ask, do cows need to take 10,000 steps a day too? Well, but before I give you the answer, let's take a step back. Every company today is a data company, even the ones you least expect, even dairy farms. Now, dairy farms have all the constraints of a modern business. Their output is milk and beef. Their inputs are the herd, the fixed herd they have, the pasture, the feed, and expensive farm labor. And the dairy farmer has to maximize the output of his dairy, milk and beef, under the constraints of those resources. So what could a dairy farmer do? It turns out there are two really important controls at the disposal of the dairy farmer. The first one, well, the dairy farmer can detect health issues in cattle very early and avoid loss of herd and loss of production. The second one turns out to be actually very interesting and important as well. They can improve cattle production by the accurate detection of estrus. Now, if you remember high school biology, estrus is when an animal goes into heat. When the time is right, so to speak, that's when the animal is ready to mate and can conceive. So this is actually super important, and this is the data from a research paper. These days with modern methods of artificial insemination, you get about a 70% conception rate, but you have to detect estrus accurately for that to work. And estrus detection, onset of heat in cattle, is done by age-old methods. You go look, and what if you have hundreds of cows in a dairy farm? Now, look, with the traditional methods, you get about a 55% accuracy, 39% pregnancy rate. But what if technology could help with estrus detection, and you could improve that to about 95%? Look at that massive improvement that you get, about 66% improvement in pregnancy rate and calf production. And that's very, very material for the farmer. Now, this is actually a harder problem than it looks. It's in many ways a needle in a haystack problem as well. Now, because estrus lasts only 12 to 18 hours every 21 days, and it's very variable like many natural processes, and often occurs at inconvenient times, like many of these things, like between 10 p.m. and 8 a.m., when farm hands have better things to do, like sleep as well. So what's a farmer to do? How can farmers tell when the time is right for hundreds of cows? Could you use technology to help? Could you build a heat map of the dairy, so to speak? Well, that's a question a farmer in Japan asked Fujitsu, our partner. So they then consulted some dairy researchers, and based on some actually already published techniques, I traced that paper back to about 2005, they came up with a really ingenious system. And this is that system. So cows are instrumented with pedometers. The step count data is transmitted from the pedometers over the internet to a service that lives in the cloud. It's Fujitsu's Gyuho, which means cow step service that lives on Microsoft Azure. And that service is analyzing the data about step counts that the cow is taking. And from the step count data, it can actually detect the onset of heat. And when they detect the onset of heat, an alert is sent to the mobile phone of the farmer, and the farmer can now take the next steps to inseminate the cow. And let me tell you the simple secret behind that. I'll illustrate this with a graph. The x-axis here on the graph is the time of night. Y-axis is the number of steps a cow is taking. So this is a normal cow on a normal night, walking, pacing a little bit, sleeping, pacing. Let's see what happens when that animal goes into heat. So this is that graph. At the onset of heat, the cow gets very restless, starts pacing around furiously. And that signal, if you take basically just an hour over hour ratio of the number of steps a cow is taking at this time versus the same time yesterday, is a 95% accurate signal for the onset of estrus. And the optimum time for artificial insemination turns out to be 16 hours from that. That's when you get the maximum conception rate. That's when AI meets AI, artificial insemination, that is. And Fujitsu researchers found some other very fascinating facts. There's an optimum time around that window, and in the first 4 hours of that window, If you perform AI, you are likely to get a female calf. In the second half, you're likely to get a male calf. Now, you're able to, the farmer has an amazing control at his disposal. He can choose with a certain probability, it's about 70% accurate. With a certain probability, you can choose whether to have female calves or males. And you can actually control the population mix. As Fujitsu analyzed the data further, they saw other fascinating things. They could, from the step counts over the whole day, they could detect about 8 different diseases of cows. And you actually could detect and alert whether a cow was sick or not. And remember that 5% false positive? Yeah, I said 95% accurate, 5% false positive. Some of that turns out to be very important as well, because some of that is when the cow jumps over the fence and skips the farm. Very important to detect as well. Well, now, the magic here is not necessarily the sophisticated analytics. It's the human ingenuity. It is the fact that a certain type of behavior is instrumented with the Internet of Things. And that data is now flowing into the cloud, and it's analyzable, and you can provide a service that provides the specific alerts required for the farmer. Building a service like that in the cloud today is actually just a few days of work for a good developer. Like many of you in this audience could take the fully managed services that exist on Azure and compose a service like that that takes data from a device, analyze it, and send alerts. It's very, very easy to do. In fact, perhaps you could maybe all learn a lot more from your Fitbit than you thought you could. That agility lends itself to enormous creativity. And that is the magic of the cloud. So now, let me tell you a little bit more about the different types of services that are available that lend itself to this. Let's talk about data science, machine learning, predictive analytics. When we have conversations with developers about data, they want to do retrospective analytics, predictive analytics, real-time analytics, and build applications with it. So earlier this year, we launched the general availability of Microsoft Azure Machine Learning, which is a fully managed service for data science and machine learning, all in the cloud. All you need is a browser to access that. There is even a free guest access. You can just log in and start doing machine learning workflows and experiments. And it supports R, it supports Python, as you will see. It supports IPython notebooks, Jupyter notebooks. It is a mixture of some of Microsoft's best algorithms from MSR and Bing, as well as open source, seamlessly all integrated, fully managed in the as a service in the cloud, elastic, scalable. You don't have to install software. It's extensible. And it is a platform that allows you one huge benefit. It allows you to publish web services with a few clicks of a button, so you can actually deploy your models right there on the cloud as APIs in the cloud without a lot of coding and development. And that is very transformative. For a lot of people who are doing machine learning, there's a huge, incredible chasm or a gulf between having built the model and developed things and putting that into production. That, in fact, takes much, much longer, months often, to actually put into production in a scalable way, tested way, deployable way, changeable way, and so on. This changes the game in deployment. The best way for me to illustrate this is with an actual live demo. And wish me luck as we actually try to create a demo that actually runs on Azure. But here's the story behind it. What I'm going to, for people from the US, some of you may know about March Madness. So this is a national collegiate basketball championships that run every spring in the US. About 68 teams, I believe, college teams play basketball. And for Americans, it is sometimes also a time to gamble. Warren Buffett, about a couple of years ago, had offered $1 billion to anyone who could correctly predict the outcomes of all the matches. Over the last couple of years, people have been gambling on this quite a bit. Warren Buffett isn't offering that anymore. But it looks like everyone wants to create their own bracket. So this is Barack Obama here on the left with the presidential bracket. And Satya actually got a lot of fame for being pretty good at predicting the bracket. He had helped a number of data scientists and some people who knew basketball. And Bing also had its own prediction service. By the way, Google has its own prediction service. Satya's predictions actually outclassed what Bing and Google and automated systems were doing. But the story I really wanted to tell you is one of a developer in our office division who knew nothing about machine learning, and a hackathon that we ran. So internally in my team, we had kicked off a hackathon to predict basketball match winners based on historical basketball match win data and other team stats, which are publicly available. And the fascinating thing was, Adam Garland, who knew nothing about machine learning, actually topped everybody. He did even better than Satya just by playing around with Azure machine learning and the data that he had provided. And not only him, but many of the teams who participated in the hackathon with Azure machine learning did extremely well. They had great scores compared to what other services were doing. And so let me illustrate what Adam Garland did. To help me with that, I'm going to have Santosh, who's a colleague of and in my team, actually run the demo. Could we switch to his PC, please, so that we can see that? Okay, so Azure Machine Learning has a gallery of examples. There are lots of APIs people have put together for anomaly detection, computer vision APIs, recommendations, and so on. If you scroll down, you will see a lot of examples that data scientists like yourself have built and shared. And you can click on one and open it in the Azure Machine Learning Studio and start running your experiment right away. That's one of the magic about hosting a lot of these things in the cloud. You can just click on and start. So for an example like this of predicting which team will win among two teams playing each other, you typically want a binary classification, a binary classifier workflow. And so we have a sample. So let's just open that in Studio, Santosh. And this is a typical workflow in Azure Machine Learning. It's a standard data science workflow. You will see data coming from the top. In this case, it is basketball historical matches. We have about 12 years of data of teams that played each other and who won. Right? And then you select the columns you want to predict on. Those are the independent variables. This then is split into a test set and a training set. You're training a model here. The algorithm is 2-class boosted decision trees, a good implementation from Microsoft. Then you're scoring that model with the test data, and you're going to evaluate the performance. So all I have to do is click Run here, and that workflow will run. And it's very easy to drag and drop and set up these workflows. Now, while that's running, let's go and see the similar workflow that Adam Garland did for his winning prediction. So this is all that it was. Yeah, he had the historical match data, for those who can't see it, and this was the average annual team stats. He joined the two with a little bit of SQL. He then cleaned some missing data that was in there. Fairly simple thing to do. You split it into 70% train and 30% score. He used an algorithm called 2-class decision jungle. It is think of it like a random forest. It is just a more efficient implementation from MSR. And he did a sweep parameter so he could try over all the parameters and pick the best one. Then you score the model with the test data and evaluate the model. That's it. So Santosh, by the way, just ran it. Santosh, let's evaluate it, and we can evaluate it here. And see the performance of that.
I just run it right now?
Yeah, right, that's good. Yeah, well, right, it is running in the cloud. It ran pretty fast, evaluation results, and you can visualize. And what you're going to see is a standard ROC curve. This is a 70.5% accuracy. Not great, but not bad. It's a very quick workflow to set up. So for something as simple as this, actually pretty good. In a very short time frame, you immediately can get the results of that experiment. But then the fascinating thing is there's a bunch of other features that allow you to explore the data here and actually publish a web service. Let's start by looking at that data. Let's visualize the data here, the average annual team stats. And let's open that in a notebook, Santosh, in a Jupyter notebook. So while he's doing that, the cool thing that we built here is IPython notebooks, now Jupyter notebooks. Jupyter stands for Julia Python R. Those notebooks are now hosted in Azure as a service. The notebook is not actually running on a PC or a laptop. It's in the cloud next to the data. It can connect to the data. You can bring that data into the notebook, interact with it, and see the details. So Santosh, why don't you walk us through a little bit of what's in there that you're showing about the team stats?
Sounds good. So this is basically our Jupyter Notebook service, which is integrated with Azure ML. What I'm going to do is bring in the data set as a pandas data frame, and then I can explore the data. I can do things such as describe the data, which gives me information. So there are around 4,000 odd rows which are in here, and it gives me information such as for field goals which are made, what is the standard deviation, what's the min max. I can look at this data in order to figure out what I want to run in my experiments. Then I can also do things. I said there are 4,000 odd data sets, so I want to actually care about a particular team. In this case, I went to Brigham Young University, which is BYU, so I want to see what is the information about BYU, explore this data. So I can set a variable and filter it down to BYU, and then when I type BYU, I get only those rows which are relevant to BYU. I can also do other interesting things. I can actually plot this data as well. I can do things such as BYU.plot, year and score, and this actually gives me interesting ways to plot and see the data. For example, BYU actually changed the coach in 2006, which was really good because our scores increased. So,
great. Now, since the model was created in Azure Machine Learning, it's easy to actually run in the cloud and integrate into applications. So we can publish web services from that. So let's see how that is done. What you have to do is actually set up a web service. Santosh is actually going to do that. Let's actually update the, let's update the predictive experiment. Let's run it. And I think you have a tab that is opened already that shows the result. Yeah. So what happens is the scoring workflow that you have now gets, so the experimental workflow that you have to develop the model gets transformed into a scoring workflow. The scoring workflow, remember, embeds the model that you learned. It applies the right transformation for the inputs that are coming in from the web service, feeds it to the model, scores it, and produces the output for the web service, right? And that's the flow here. The input is coming in. The transformations are preserved. If you scroll down, you'll see that the model that was trained is preserved here. You score the model, you publish the web service output. Now remember, in the scoring workflow, you can actually insert other modules if you like. You can put in other transformations, you can put in other code, you can put in Python code. So you can actually create a full application with the model that you just trained that's completely distinct from the experiment. Right? Remember, the production workflow is always going to be different because it's an application you're creating with the machine learned model. And that's actually very, very easy to do in Azure ML as well. And so now all you have to do is actually publish the web service, run it and publish the web service. You have to run it once so that the scoring workflow runs, and then this will become available to deploy. And so it will turn into a deploy web service fairly soon as it runs. By the way, as we speak, this is actually running in the US in the cloud. And I'm actually very happy the whole demo stayed up, and it actually is quite reliable. So let's see that web service that gets published. I think you should just open the tab.
I have a tab which is,
just for ease. So what you get is a page like this. This is the API key. So a web service API has been created live as we spoke in the cloud, completely hosted, scalable, ready to accept data. That is the key. It's a REST API, so you can easily call it. Let's click on the API help page here. And you'll see a detailed help page. This is the OData call that you would make. This is the post call that you would make. That's how you would access that API. Let's click on the sample code. It automatically generates sample code. You have C#, Python, and R code. For anyone familiar with Python, you will see there's a very simple way to call it. You put the API key in there, and this Python code is executable from any Python application. You can also have R code, C# code. You can easily integrate with any application that you like. Let's show that actually now working, calling that API that was just published live from a Jupyter notebook. Okay, so the same Jupyter notebooks that I showed can be opened up. We can put in a little bit of code. Let's open that now. A little bit of code in there to actually call the API with live data, and Santosh will now take us through that.
Yeah, so what I'm doing is that web service which was created, I'm basically taking the URL, the key, some information about the web service to create the method to see which team wins. And once I do that, I put the two teams, Duke and Wisconsin, actually played the finals this year. It says that Duke will win with a probability of 54%. Believe it or not, it was a very close game. I think Duke won only by 5 points. So this was actually very true. One other thing, all of the things that I'm doing here is being auto-saved as well. And you can go back to the ML Studio in the notebooks, and you can see all the notebooks which are here. So there is a seamless integration between what we are doing.
Right. So it allows you to save your experiments as notebooks in Azure Machine Learning, and there's a whole tab. You can share the notebooks. If you actually click plus new here, Santosh, you can actually open up Notebook tab, and yeah, if you click on the Notebook tab, there will be example notebooks that are there. If you click on that, yeah, can you click on that?
Yeah, I am.
Anyway, yeah, so you'll see notebooks that are saved as well, examples that are provided by other people. So let's switch back to my PowerPoint here. Okay. So now connected data is not only massive, it's constantly moving. Data is in motion, right? Data from sensors, from web services, all of that is coming in. And one of the cutting edges of analytics today is stream analytics. How do you analyze data as it's flowing in and understand insights from it? Now, in Azure, we have some great services for it, fully managed services like Azure Stream Analytics. And I wanted to show this happening again live. What I'm going to show is an actual anomaly detection demo, data coming in from a device that's actually going to sense the temperature and humidity here in the room and see how much hot air we are generating here, and drive alerts from it, right, in real time using a machine learning model. So this is sort of the flow. Data is coming in from a sensor. Event Hubs is used to ingest the data into Azure in the US. Stream Analytics runs on it, calls a machine learning service, an API that has been published to detect anomalies in the stream of data, drive an alert, send to a dashboard, and also drive some devices. So here's what we are going to use in the demo. Santosh has a device which is a Bluetooth connected sensor, a temperature and humidity sensor that's connected over Bluetooth to his laptop, I believe. And the data is going to be sent to Azure, the cloud. Analytics is going to be done, and we are going to generate some alerts. Can we switch to Santosh's laptop again, so for the demo? Okay, Santosh,
Hi
take it
guys,
away.
what I have in my hand is a Texas Instruments sensor called Sensor Tag. This, what you see on the screen, is actually the live temperature, humidity, and other things which are there right now. This actually has an accelerometer, magnetometer, and everything. This is a BLE device which connects with my laptop, and we stream the data directly to Azure. In Azure, there are services such as Event Hubs. Event Hub is a service. It is a service where you can connect thousands of your sensors. So all of these sensors, if you're doing building monitoring, you could connect to it, stream the data seamlessly. Once you have the data there, which is streaming, you want to do some analytics on top of it. For that, we have services like Azure Stream Analytics. It's a fully managed PaaS solution, or it is scalable, reliable, everything. All you have to do is just write your logic, your stream processing logic in SQL. So let me show you what we did right now. You actually saw this go off, right? I'll actually show you how an anomaly was detected, and these two devices are completely disconnected. These are not talking to each other through anything but the Azure cloud. So this is coming in. I have a small app which is pushing it to Azure, the Event Hubs. From here, I have Azure Stream Analytics. As you can see, in order to create just this BI dashboard, it's a very simple SQL-like statement. This is actually sending a lot of data, including health data, but I just want the telemetry data. That's how I filter it out. I push it out to a BI dashboard. In order to call anomaly detection, which actually happened, what we have is the same concept that we have of the web service. I have an anomaly detection web service, which is also there in the gallery. We have operationalized it. And I can call this anomaly detection web service over the same sensor data with a user-defined function. In this, I'm saying I want to send the humidity. What is the time? This is the time series function. And I want to send this 30-second history with a hop of 1 second. So every second, I want to send 30 seconds. And that is it. This anomaly detection function gets the data, analyzes it, gives us the results. We look at the results. Here I'm looking at the RP score, which is coming. And once we say that an anomaly is detected, we push it out to Event Hubs. We can push it out to a BI dashboard. You can get phone calls over it. And what I really showed you was once how this anomaly was detected through the Azure cloud, through Azure ML, back into Event Hubs. There is a service which runs it, and you saw this device which actually came up. So hope you can understand this decision-making and command and control that we are doing through Azure.
Right.
So,
So let's switch back. So what I have shown you here is how easy it is to wire up an end-to-end IoT solution on Azure, right? From getting data from that TI sensor all the way into the cloud, doing real-time analytics, calling some existing APIs, it all requires very, very little code. And the stream analytics itself, because it's fully managed, you don't have to compile Java code in Storm and set up spouts and all of those. It's extremely easy to configure stream analytic computation in the cloud. You don't have to install software and wire up a lot of complex things or compile things. And you can call ready-made APIs for in the cloud, such as for anomaly detection, and you get the results back. And it's extremely easy for developers to do so. And that agility is what we are driving with the innovations that we are making in analytics in the cloud. So now let's step back a little bit and think about the bigger picture. Now, typically, when you want to do analytics in the enterprise, you want to address data at various stages of complexity. For example, the basic thing that you do in the enterprise today is to do reporting. You do reporting on the data, which tells you what happened. So then people take some time to think about it, go through a manual process, take decisions and take actions, not necessarily scientific or sound, but that's how a lot of businesses work today. Now, if you're a little bit more sophisticated, you would ask, why did whatever event you were looking at happen? You would use statistical analysis on it. You would then have a more informed decision that can drive action. If you go a little farther, you would do predictive modeling. You would do what will happen. That gives you insight into what will happen in the future with certain statistical confidence. You take actions from that. But ultimately, what you want to get to is complete automation. You want the system to be able to say, what should I do? And that allows you to take actions directly and automate decisions. And if you're sensible, you would follow Ronnie Kohavi's advice from today morning and do a lot of experimentation before completely automating the systems that you're trying to automate. So you know the actions have the desired effect that you're actually intending to do. Now, when an enterprise wants to do a lot of these things, it is actually a lot of work. It requires today integrating components from a very, very diverse collection of vendors, things that don't necessarily interoperate well, don't have great SLAs, you don't know how to connect all of them up. And so we took a step back in Microsoft and asked what would be sort of the distro for analytics and intelligence, especially in the cloud. We wanted it to be really cloud first. And we created this suite of components we call the Cortana Analytics Suite that covers everything from ingestion of data to managing the information. So there are services like Azure Data Factory, which allows you to do ETL in the cloud, set up data pipelines in a very graphical way, very simple to set up and manage and monitor complex pipelines for orchestrating data movement. You then have things like Azure Data Catalog that provides a catalog of all your enterprise data, so you can discover what's actually available for you to model on. You have Azure Event Hub. We have big data stores like Azure Data Lake, which is a big data store, HDFS API in the cloud, fully managed. You don't have to set up Hadoop. You don't have to worry about clusters. You just send it big data and manages it at exabyte scale and provides you enormous bandwidth through the HDFS APIs. We have an Elastic SQL data warehouse. Elastic data warehouses are actually a first. There are not many people who have ever been able to create data warehouses that can scale up compute or shrink down when you don't need it. It runs on the data that actually lives in Azure storage. You fire up compute when you want it. You run the data warehouse computations. And when you don't want it, you shut it down. And then services like machine learning, Hadoop, stream analytics. And then we took Cortana. Cortana is a personal assistant now integrated with Windows 10 that is an intelligent personal assistant. It understands context in which you're working. So it can provide you relevant answers to questions. You can interact with it in natural language. And it is also a notifier. It can notify you proactively about things that you care about. What if you could bring that magic to the enterprise, the enterprise's information stores, And enterprise developers could configure the inputs into Cortana for the information workers so that relevant information is surfaced. And so we brought that in as well. And there are other features here. I won't go through all of the details, but you can see more of it at this URL, microsoft.com/Cortana Analytics. And again, maybe the best way for me to bring this to life is through a real-life case story. And I'm going to actually play a video of a hospital using many of these Cortana Analytics components for predictive healthcare.
The U.S. healthcare system is challenged by the task to deliver exceptional, personalized care at a lower cost. Despite spending nearly one-fifth of our gross domestic product on healthcare, we struggle to meet this goal. Financial pressures on care providers are increasing. This isn't sustainable. So how can we deliver high-quality, personalized care that patients deserve, given the cost pressures we face? At Dartmouth-Hitchcock, we've created Imagine Care, a new cloud-based solution built on Cortana Analytics Suite and Microsoft Dynamics that enables providers to help patients achieve better health. With the help of Microsoft, Dartmouth-Hitchcock is building a technology platform to serve healthcare organizations and patients across the country, setting a new standard for personalized care. Now, using machine intelligence, providers can develop a care plan that's unique to each patient. We can monitor patients from their homes, where data is collected from devices and sent to the cloud, to Imagine Care's 24/7 contact center, where registered nurses continually monitor a patient's health status and potentially serious trends.
Cortana, summarize health status for Ben Andrews. Ben Andrews' weight has increased more than 2 pounds in the last 24 hours. Please review the home dialysis protocol prescribed by Dr. Phillips.
Patients get reminders and encouragement and dynamic updates to their care plans, improving their health, helping them avoid unnecessary trips to the emergency room, and reducing the cost of care. With support from loved ones and real-time interventions, there is less likelihood of readmission. With Cortana Analytics Suite and Microsoft Dynamics, we're transforming the way healthcare is delivered today, improving patient outcomes, reducing costs, and offering an unprecedented level of personalized care.
Predictive healthcare is really the future of healthcare. For example, it's not just this hospital, but for example, Ankur Tardashai and his team in University of Washington, Tacoma, have built hundreds of models for conditions as diverse as asthma and cardiac care, and are deploying it with Azure Machine Learning and piloting it with hospitals. So big data and analytics can indeed change lives. So let me conclude here with stepping back and talking about a little bit of the transformation that is happening today. Now, the cloud is changing the way development happens. It's turning hardware into software. People don't buy servers anymore. Hardware is developed, hardware is delivered as services in the cloud. It turns software into services. Nobody installs software anymore. It's just available as a service in the cloud. You just connect to it and start using it. And it's now turning data into intelligence. It lets developers be smarter, makes them much more agile, and drives an unprecedented level of creativity. Thank you.
Thank you, Joseph. We have time for a couple of questions. So, any controversial questions for Joseph? Yes.
Right.
We have auto manufacturers that have millions of cars, each of them have hundreds, maybe thousands of sensors, and what they do really is they embed whatever diagnostic results in the model inside these pieces of cars, versus going back to every application of the car. Where does the manufacturer?
So I will repeat the question. So the question was, there are lots of sensors and devices. People often just take the data and do the analytic they need locally next to that sensor. If it's a car, there are sensors in the car. There's a computer in the car. You can do the analytics locally. Why run into the cloud and back, right? And so the answer to that, I mean, there's going to be a full spectrum. When you know exactly what the analytic you want and the sensor, in fact, sometimes you don't even need a computer. You can actually have an electronic circuit that does everything, right? And that's how the world has implemented these things in the past. So why did then the computer come in? Because you want to do more sophisticated analytics. And why does a cloud come in? When you want to actually leverage a lot of historical data that might be there, compute things that are a lot more sophisticated, also do exploration of all of the data that is being collected, redeploy models, have very large numbers of models potentially deployed, try champion challenger things, and so on. It allows you just to step up the analytics that you do to a new level. And so now here's the magic that happens, right, with unlimited compute in the cloud and these sensors that are connected with high bandwidth. You have these sensors which require very, very little computer, extremely cheap, don't need CPUs, that live all over the place, all around us. And you have this enormous brain power, enormous compute power in the cloud, and every one of these sensors can connect to that enormous compute power that's available in the cloud and leverage intelligence at a massive scale. So the planet becomes intelligent. That's the promise of the connected cloud.
Yeah, that's an IBM tagline.
I didn't copy it.
One other question in the back. We have a mic. If you can run the mic over there.
Yeah, over there.
Yeah. Thank you.
Hi, I'm Hejong Kim from Texas A&M, and I actually, your last demo was very interesting because that's exactly what I was talking about with my colleagues at A&M last week. We were doing this, and the two things I was thinking about the whole time I was looking at your presentation was, because that's what I was thinking about, I was thinking about how do I use what you just demoed for what I'm doing in research. And what I had in mind the whole time was, in healthcare, as you know, probably, you've seen all of this, right? When you have data streams flowing, you have to deal with encryption and HIPAA.
Yep.
And on top of that, if you've got a system going like that where you're prescribing, let's say, software services, that's actually medical software, and so you have to deal with regulations and FDA.
Absolutely.
Even the A/B experiments you were talking about, which I really enjoyed, those work when you're talking about websites. That's called human subject experiments. That has a lot of other regulations. You have to even get approved, so you cannot do this agile, quickly try this demo, that demo until one works and one doesn't. So how do you deal with all of that in terms of the healthcare setting?
Yeah, it's a great question. But then healthcare is a vast space, remember. There is a tremendous number of things that you can do. What you said, first of all, Azure is HIPAA compliant. For a lot of these things, there is always a human taking a decision. We are not actually prescribing a specific action necessarily, but again, humans are configuring the recipes for a proactive nurse practitioner to follow. So there's a human in the loop with a decision-making capacity. It is just really having that entire loop being appropriately audited and approved. And when you're talking about experiments, these are not experiments on patients necessarily. It's about analyzing data and looking at various options. Turns out it's actually a pretty big space, and the people who are doing this work are actually hospitals who are actually following all of these. We are really, at the end of the day, a platform provider, remember? And we work with them for the certification, data security, and all of those things.
So we are running out of time. I'm sure Joseph is going to be around for a while. I'm going to ask him one question before we thank him. How many people here use R? All right, so this is the guy who acquired Revolution R recently. I'd like to ask the last question. Why did you do that, and how is this going to be beneficial to us?
Yeah, it's a great question. Remember, we really believe in the power of open source. R is really amazing because a community has created some of the world's best data science packages. Revolution R made it enterprise grade. It packages for use in enterprise has to be well tested, has to be validated. You have to have distributions that are static, that you can reliably build on. We brought all of that. So we brought Revolution, and we bought Revolution Analytics to do two things. First, big commitment to R. Potentially amplifying open source in many ways through providing features like testing capabilities, bringing that to the enterprise. The vast majority of students coming out of the universities today learning statistics have learned it in R, giving them a great path to working effectively in the enterprise, and then finally integrating that very seamlessly with our cloud so that the cloud becomes the best place for operationalizing analytics at scale using R. At the same time, keeping ahead of the times as people innovate in statistics and elsewhere and contribute packages to this community.
Please join me in thanking Joseph for an amazing talk.
Thank you. Thank you.
I'll take your picture before you leave.